Beautiful people, and welcome. In this video, we are graphing quadratic equations, quadratic functions, given the equation in vertex form. Now, this form I also call the pretty point method because all the points just end up being very pretty, very perfect, and easy enough to sketch. Let's start with our steps. Step number one is to identify your vertex. Now, your vertex is going to be your h comma k. Now, for h, because it is inside the bubble, it is inside the function, right? Inside the parentheses. You always want to do opposite of what you see. So if you see a minus here, that means h is going to be positive. If you see a plus here, that means h is going to be negative. So make sure that you do opposite of what you see. Now for your k value is exactly what you see. You don't change k. So if you see a plus k, it's going to be a plus k. If you see a minus k, it's going to be a minus k. That doesn't change. Step number two is to make a t-chart. You're going to write your vertex here in the middle. The reason you want to do it in the middle is because you're going to choose a value one higher than the x and one lower than the x. For example, if h was 3, I would do x is 4, and I would do x is 2. So one above, one below. Once I have my new h values, I'm going to take those x values, plug it into the original equation, and solve for y. And then make sure that once you have sketched it, your curve matches your a value. What I mean by that is if your a value is positive, make sure that you have a happy u. If if a is negative, your leading coefficient, if it is negative, you're going to have a decreasing function. So let's go ahead and do an example. Now, if you're in my class, this is very similar to how we were graphing absolute value equations, since it was also in vertex form. So here's an example for us. Okay, step number one is to identify your vertex. Your vertex here is your h comma k, and again, opposite of what you see. So if you see a positive 4, it's actually a minus 4. Now your k value, it's the same. That doesn't change. So if I see a minus 2, it stays as a minus 2. Step number two is to write your t-chart. Here's your x, here's your y. You're going to place the vertex point in the middle. Step number three is to go one above, one below. So I'm going to have a -3 here and a -5 here. Then I'm going to take my original equation, which is here. F of x is just another way of saying y. So here's 3 times x plus 4 squared minus 2. And I'm going to plug in my new x value. So I'm going to substitute in for -3. And then the next time I'm going to substitute in for a -5. Now here, again, with the help of a calculator, if you need it, -3 plus 4, that is 1. 1 squared is 1. 1 times 3, so this is 1 squared. Make sure that you multiply before you subtract or add. So this is 3 times 1, 3. Again, make sure you multiply before you subtract. 3 minus 1 is positive 1. So when my input was -3, my output was a positive 1. I'm going to do that one more time. So I have y equals 3 times x plus 4 squared minus 2. I'm going to do that, but this time my input is going to be a -5. Again, with the help of the calculator, if you need it, -5 plus 4, that is -1. -1 squared is a positive 1. 3 times 1 is 3 minus 2. That gives you a positive 1. So when my input was -5, my output was 1. So let's go ahead and sketch that out. Now, this form is very important for you to understand what your parent function looks like. What kind of equation do we have? Because this method is so similar to the absolute value method. However, the absolute value function is a V shape versus the quadratic looks like a U. So make sure that you look at what the given function is so that way you know what to graph. So we have a -3 and a positive 1. I have a -4 and a -2, and I have a -5 and a positive 1. So again, if you look at this, you have 3 points. It could potentially look like a V. It could potentially not look like a V. It could look like a U. So make sure, because our given function is a quadratic, meaning it has an exponent of 2, it must look like a U. And you are done sketching. All right, let's go ahead and do one more example. Again, pretty point method. Step number 1, identify what your vertex is. For your vertex, make sure you take the opposite of your h value. So in this case, I see a -3, so it's going to be a +3. And your k value stays the same, so if you see a +1, it's going to stay as 1. Step number 2 is to write it in your t-chart. So I have a 3, 1. You're going to choose a value that's above it and below it. So I'm going to have 2 and a 4. Taking my original equation, I have y or f of x. It depends on whichever you want to write. X minus 3 squared plus 1. So I have -2 times, I'm going to put 2 in first in place of x. 2 minus 3, that is a -1. So I have -2 times -1 squared, which is a +1. This is -2 times 1. Do that first. Then we have this +1, which gives me a -1. So when my input was 2, my output was -1. And doing that one more time, y is equal to -2 times x minus 3 squared plus 1. When my input now is a +4 minus 3 squared plus 1. I'm going to shift this up just a little bit so you can see it better. So I have -2 times 1 squared plus 1. -2 times 1 squared, that's just 1. So I have -2 plus 1, which gives me a -1. So my input was 4, my output was -1. Doing a quick sketch here, I have a 2 and a -1. I have a 3 and a +1. And I have a 4 with a -1. Again, make sure that you are aware of what your parents look like, right? So here's your parent function with an exponent of 2. That means it will look like a U. So you're going to curve downward, connecting, and you are all set. All right, beautiful people, thank you so much for watching. I will see you in the next video. Bye.